Okay guys, hope y'all are doing well. I realized when I did my video on part 1 of section 8.3, when I didn't have my calculator, that actually made it to where I didn't fully explain those examples. And so I'm going to come back and I'm going to do these problems on your homework. So if you actually have these numbers on your assignment, then I guess you're welcome for the free answers. But if you don't have these numbers, then hopefully this will help you to understand how to answer these problems. So what we want to do is we want to plot the complex number 7 minus 6i in the complex plane and then write it in polar form. So remember, 7 minus 6i is like plotting the point 7, negative 6 in the complex plane. And so we know that that point is going to be in quadrant 4 since it has a positive real part and a negative imaginary part. And the only answer choice here that is in quadrant 4 would be letter A, and it tells us that that is correct. Now, the second thing it wants us to do is write the complex number in polar form. So just as a reminder that polar form is r times cosine theta plus I times sine theta, and we need to find r and theta. So to find r, we know that there's a formula. This is going to be the square root of a squared plus b squared, where a is the real part, in this case 7, and b is the imaginary part, in this case negative 6. So this will be the square root of 7 squared plus negative 6 squared, and so that will be 49 plus 36, which ends up giving you the square root of 85. Now you'll need to make sure that you simplify that radical if possible. It just turns out that there are no perfect squares that go into 85, and so square root of 85 is already simplified. Now, in order to find theta, our formula is tan inverse of b divided by a, where b is the imaginary part and a is the real part. So this will be tan inverse of the imaginary part, negative 6, divided by the real part, which is 7. And make sure that your calculator is in degree mode when you do this, because if you'll look at the directions in blue on the left of your screen, it's going to tell you to type the angle measure in degrees. So when I type this in to my calculator, what I end up getting is negative 40.6012, etc. Now, what you need to realize is that this is the reference angle. It is not the answer. This is not what you're going to type in as your answer to part 2 of this question. This is the reference angle, and furthermore, remember that whenever we have reference angles must always be positive. And so really we're going to regard this as positive 40.6012 whenever we go to find our answer. So what do we want to do here? We want to go in quadrant 4, since that's where our point is. Here is my reference angle, my 40.6012, and I know that this right here is 360 degrees. So my theta is going to equal to 360 minus 40.6012, etc. And whenever I round that to the nearest tenth, what I end up with is 319.4. And so when I come over to type this into the answer, I'm going to have square root of 85, and then for my angle, 319.4. And this should give us the correct answer. So again, make sure that you're recognizing that that's the reference angle that you're going to get in the calculator, and then you have to make sure that you put it in the correct quadrant.